Welcome back. So we are studying about the analysis of the circuits using nodal analysis and with the emphasis on the supernodes. So this is a very good example that basically combines the multiple concepts that we have explored in the different examples of earlier videos. Okay, where we discuss only supernodes, where we discuss the circuit with only dependent sources. Now in this circuit we have all those things together. Okay. So first thing we can notice here that we have three nodes, okay, V1, V2 and V3. The target is to find I naught. So I naught is the current through 12 kilo ohm, okay. So we can write the equation for this variable, that will be basically what? V1 minus 0 divided by 12k, okay. Then we need to find Vx. Vx is a voltage drop across 6 kilo. So if you look at this circuit, Vx is basically the voltage drop between this node and this node, which is 0. Or in other words, we can say that basically Vx is nothing, it's just V2. Okay, so basically if we find the value of V1 and V2, we can find our desired variable values. How we can find V1 and V2? We are putting focus on nodal analysis. So nodal analysis, we need to write the equation for every node. So before writing the equation for every node, what are the first steps? We need to identify, is there any independent voltage source between that node and ground? If you found that, directly get the voltage value. Which one is that in our circuit? So for our circuit, that value is basically this voltage source here, right, which is connected between this and ground. I can directly get the result that V3 is basically 6 volt. Okay. So value of this resistor is basically 6 kilo, which is basically missing here. All right. Next, we don't have any other voltage source here. Okay, we have a dependent voltage source, which is basically 2Vx. Okay, and the beauty is here what? Basically, this dependent voltage source is connected between node V1 and V2. That basically make a supernode. So we have a basically a supernode, which is in other words is also a dependent voltage source. So let's write the supernode equation. What will be that? V1 minus V2 is equal to 2 times of Vx. And basically what is Vx? Vx is the same as V2. We have already found that. Okay, so what I can do here, I can rewrite this as V1 minus V2 is equal to 2 times of V2. But if you do the rearrangements, like if I take V2 here, so what will be that? V1 minus 3 times of V2 is equal to 0. So we got our second equation. This is basically of the supernode equation. This was our first equation. After that, what we can do? We can just write the KCL equation, nodal equation for this supernode. All the currents leaving. What is the currents leaving from this one? With reference to V1, this current, what is that? V1 minus 0 divided by 12k. Then this current, what is that? Through 6 kilo with reference to V1. V1 minus V3. What is V3? 6 volts. So V1 minus 6 divided by 6k. Then we come to V2. What are the currents with reference to V2? This one through 6 kilo. What is that? V2 minus 0 divided by 6k. Then through this one, what is that? V2 minus V3 divided by 12k is equal to 0. And what about the value of V3? Basically 6 volt. Okay, so we can put that value directly here. So multiply the whole equation with the 12k, the biggest one here. So 12k and 12k cancelled. I have V1 6, like 12 divided by 6, we got 2. So 2 times of V1 minus 6 times 2, 12. Again 12 divided by 6, 2 plus 2 times of V2, 12 cancelled, plus V2 minus 6 is equal to 0. Rearrange 2V1, 2V2, V2. We have what? 3V2. What are the constants? Sorry, we have V1 here. So V1 plus V1, that will be basically 3V1. 2V2, 1V2, 3V2. Then we have minus 12 and minus 6. That will be minus 18. Goes to the other side, become 18. Okay, or this could be further simplified if we divide with all with 3. So v1 plus v2 will be 6, right? That we can just get another simplified version of this equation. So this is my equation 3. So if you compare equation 1 and equation 3, we have two unknowns, okay, and we can find that easily. I can say that basically from equation 2, okay, like from this equation, I can write that v1 is nothing, it's just 3 times of v2, right? So let's put that here. 3 times of v2 plus v2, that will make 4v2 is equal to 6. So v2 comes out to be 6 over 4, okay, and what is exactly this value is? Okay, so 6 over 4 is just 1.5, right? So this is v2 value, okay. So let's put that back in the equation here, okay, to get v1. So what will be v1? 3 times of 1.5, what is that? 4.5 volt, right? So we have got the values, okay, for all the cases, right? Our v1 comes out to be 4.5 volt, right? And v2 comes out to be, this is 4.5 volt. Let me just put the values on the circuit just for the reference. So v1 comes out to be 4.5, v2 comes out to be 1.5, and v3 is already 6 volt. All right, so we got all node voltages. We need to find basically I naught. I naught is v1 over 12k, so let's put that here. So I naught will be what? 4.5 divided by 12k. So what is the answer? That is 0.375 milliampere. Okay, so we got our first desired variable value. Second is Vx is equal to V2. What is V2? 1.5. So we can simply say that the value of Vx is basically nothing, 1.5 simply, and we got our second desired voltage which was required here. So this is a way to solve such circuits. Okay, thank you so much.